Hello and welcome to the Minds on the Frontline podcast, a podcast dedicated to meaningful conversations that inform, educate, and inspire frontline workers, their families, and the public. Our mission is to shed light on the mental and behavioral challenges faced by those on the front lines while providing valuable insights and real-world solutions. Minds on the Frontline is brought to you by the Frontline Strong Together 5 program. FST5 provides streamlined access to behavioral and mental health services and crisis resources for Michigan's Frontline 5 workers and their families. This includes all professional, part-time, and volunteer firefighters, EMS, law enforcement, corrections officers, and 911 dispatchers in Michigan and their immediate family members. First responders and mental health experts collaboratively created FST5 to provide 24/7 live support, effective resources, and cutting-edge services to prevent and alleviate PTSD, anxiety, depression, and other frontline work-related mental and behavioral health challenges. Need help now? If you are a frontline worker in Michigan or an immediate family member experiencing any crisis, whether it's work-related, substance abuse, depression, relationship, finances, or any other, reach out by calling 1-833-34-STRONG or go to fst5.org for more information. I'm Jeff Lassers, one of your hosts. I'm a professional firefighter, paramedic, educator, and content creator. Minds on the Front Line is co-hosted by Mike Mattern, also a professional firefighter and paramedic. In addition, Mike is a peer support team member for his fire department and the FST5 program. In this episode, we welcome Dr. Vaibhav Diwadkar, a professor of psychiatry and behavioral neurosciences at Wayne State University. With decades of experience in cognitive neuroscience and brain imaging, Dr. Diwadkar offers a powerful and academically grounded perspective on stress, resilience, and mental health. Dr. Diwadkar worked directly with Wim Hof, the world-renowned figure known for his ability to endure extreme cold and push human boundaries. Through this collaboration, Dr. Diwadkar and his team studied how the Wim Hof Method, combining breathwork, cold exposure, and focused mental training, can improve emotional regulation, lower anxiety, and literally reshape how our brain responds to stress. His findings show that this practice creates a hormetic response, which is a short, controlled dose of stress that over time builds up the body and mind's resilience. For first responders, this is more than just a theory. It's a practical tool for training mental toughness, managing stress under pressure, and staying focused in the chaos of emergency situations. Think of it like this. It's a microdose of extreme adversity done in a controlled and safe environment that teaches your brain and body how to stay calm and in control when it matters most. Many participants describe feelings of calm, emotional clarity, and even enhanced mood. All these experiences align with Dr. Diwadkar's neuroimaging data showing activity in brain regions involved in stress response and emotional regulation. This episode is more academic than others, but it's also deeply practical. Dr. Diwadkar's research bridges science and real-world application in a way that could reshape how first responders build and maintain their mental resilience. As with any wellness practice, please consult a medical professional before attempting cold exposure techniques, especially if you have underlying medical conditions. Please check us out on YouTube, Instagram, Facebook, X, and LinkedIn, and make sure to like and subscribe to all Minds on the Frontline podcast social media channels. Thank you, and enjoy the show. Good morning, sir.
Good morning to you.
Morning.
Thank you for having me.
Thanks for coming on.
Yeah.
Absolutely my pleasure.
Our neighbor.
Yeah, we're just a couple offices away from you.
And this is the first time we've sat down and gotten together.
Isn't that funny how that works? Well, we're going to change that. We want to get to know everybody on this floor. But before we do, we want to get to know more about you, sir. Why don't you introduce yourself, who you are, what you do, and where you do it?
My name is Vaibhav Diwadkar. I am a professor of psychiatry and behavioral neurosciences in Wayne State University School of Medicine in Detroit, Michigan.
Right on. And who are you as a human? You're a husband, you're a dad?
I was a husband before I became a dad. And now in some circles, I'm known as my wife's husband. In other circles, I'm known as my daughter's father. And in a very small circle of people, I'm known as a professor of psychiatry.
Right. Isn't it funny? We got all these different walks of life and our status changes.
It teaches you humility.
Yes.
Absolutely.
Yeah. I have 2, 6 and 4, and I am humbled
every minute I am
Yes.
home.
Yes,
Okay, hero, you came in through the door. Cool. Take out the trash.
Yeah.
exactly.
Yeah.
Kids need baths. Get on it.
You're not a captain at home.
Yeah.
Yeah.
So share a little bit about your background. What got you interested in the neurosciences?
So I arrived in the United States as an undergraduate. I'm originally from India, though I spent more of my life in the US. And I arrived as an undergraduate to study computer science. And the India that I came from, there was almost no sense of psychology or neuroscience. This was the mid-'80s. It was very much engineering or medicine. And so I arrive here and I'm studying computer science. And so I'm in the library of my undergraduate institution. And of all things, I pick up a book, which is a adapted screenplay that Jean-Paul Sartre wrote on Sigmund Freud. And the goal was to make it into a movie, but it never made its way into a movie. And I started reading it, and it was just enormously interesting. So again, coming from where I came from, I had heard of Freud, but I had very little sense of sort of what Freud's work was. And so rather than this screenplay being just a screenplay, for me, it became an introduction to psychology, to a very particular branch of psychology. And so I finished university with a double major in computer science and psychology. And then I went to Nashville, Tennessee, to Vanderbilt University to do my PhD in something called cognitive neuroscience or cognitive science.
Very interesting. Now, before we connect the hormetic response to resilience, I want to dive a little bit more of what you do specifically here to kind of connect into our topic today. So what do you do here that leads into that hormetic response and resilience?
If you think about the need to study brain function, well, how do you study brain function? Till 100 years ago, you just couldn't. About 100, 110 years ago, people understood or began to come up with ways to study brain function in animals. And so they were able to implant electrodes on the brain of animals. The idea emerged that you could link or you could correlate measurable responses from the brain with the behaviors that the animals were engaging in. And so the idea emerged that brain responses really are a fundamental driver of behavioral responses. The question was, how do you study the human brain? And I don't mean a brain that is fixed in formaldehyde or a sort of the structure of the brain using some method that doesn't give you access to function, because you really want to study the human brain in vivo. In vivo means in living tissue. And so it so happened that about 35 years ago, a method called functional magnetic resonance imaging. And functional magnetic resonance imaging allowed us to understand some aspects of brain function in a very poor way, in a very limited way, but nevertheless in a way that you could actually collect signals. And even though the signals of themselves didn't mean anything, you could use mathematical methods to try and squeeze out information from that signal. And so what we have been doing in our work is we primarily use functional magnetic resonance imaging, and we use it to try and study brain function. So we have participants participate in tasks. We need the tasks because those are the accelerant to the brain, if you will. So in the way that a cardiologist might put somebody on a treadmill, have them do a stress test to see how healthy is their cardiovascular system. You don't do that just with the resting heart rate or resting blood pressure. You want to stress the system. By stress, I mean you want to make the system move.
Gotta get the juices flowing.
Get it going. Exactly.
Yeah.
See it in action. So we do a lot of what is called task-based functional MRI. So we use very basic kinds of tasks. And when I explain them to you, you might say, well, why do you use this? Why do you have people tap their fingers to a stimulus that comes up? That seems completely uninteresting. And actually, it is behaviorally uninteresting. But from the perspective of the brain, it's enormously interesting. Because if I sit here and I'm asked to tap my finger to squares that come up, and the squares can be red or green, and I'm told, tap my fingers whenever the square is green, but don't tap to a red square. And I don't know when the red square is coming up. Now, this is an extremely basic way in which to look at methods of motor inhibition, because most of the time I'm tapping my fingers, but all of a sudden I have to stop. Now, this is very interesting for the brain, because how does the brain implement this process? And it turns out that it doesn't implement this process in a very simple way. We actually don't really have a clear idea of how this kind of basic process is implemented in the brain. when you think about it, this framework is very general. You can use it to study healthy brain function. You can use different kinds of tasks, like memory tasks, to study conditions that are associated with impaired memory. And so, as you can see, this framework is very general. You can study almost anything with it. And again, what you learn is not conclusive in and of itself, but it gives you a little bit of insight, sort of a little bit more knowledge than you had about what the brain is doing.
You're basically stimulating the brain in a way using fMRI to produce data and then trying to figure out how the brain did that.
So we use behavioral tasks, exactly, to drive the brain. We then co-acquire the fMRI data while participants are engaged in these behavioral tasks. And of course, the assumption is that the data that we are collecting, the fMRI data that we are collecting, reflect what the participant was doing during the behavior. So in a sense, it's a signature of the behavior in the neuroimaging data.
And that allows you to pull patterns, to understand it, to look for correlations.
Exactly.
Cool.
Exactly.
That's really cool.
Yeah.
Okay, so help me understand what the hormetic response is, how you're studying that, its place in there, and its relation to resiliency, both physical and mental.
A colleague of mine and I became very interested in how the human brain responds to cold stress. This actually is a very understudied question for reasons that you might well understand. It is very difficult to use cold stress paradigms in humans. So for a lot of the studies, what people had done was use sort of topical application of cold stimuli to understand how people respond to the alternation between cold stimuli on your forearm versus warm stimuli and so on. That actually is not what we would call human thermal regulation. Thermal regulation is the autonomous systems in our brain that we don't understand what they're doing. So we think, or we have assumed that they're not under our control, that regulate our core body temperature. Humans are what are called homeotherms. So we maintain our core body temperature. We cannot change it greatly, unlike some other species. We have to maintain it within a very narrow range for survival. And the question is, how do we do it? So this has been humongously studied in animals, as you can well imagine, and primarily in rodent models. And so in rodent models, people have, collected electrophysiological signatures, electrical signatures from inside the rodent brain, and you can subject rodents to different kinds of ambient temperatures. You can do very controlled experimental studies on how their core body temperature changes, and then understand how regions of the brain, like say the hypothalamus and so on, how they change. And so these studies have been very detailed in rodents, and that was pretty much almost the only literature that ever existed on thermal regulation. Now the question is, does this generalize to humans? Well, why should it? Humans are not like rodents. If you're thinking about an evolved system like thermal regulation, you have to assume that that is very much related to the ecology of the species. We don't live like rodents. We don't live in hostile environments. We don't actually grossly change our core body temperature. We change the environment. And if we feel cold, we don't sort of will ourselves to feel warmer by thinking about being on a warm beach. We go and put on a jacket. And so we warm ourselves. And so my colleague Otto Music and I, who's also a professor here, we became very interested in this question. And so we needed the appropriate apparatus to study this experimentally with functional MRI. And so the apparatus that we came up with, not that we came up with, it has been in existence for a while. It's this cold suit. And it's a cold suit that has primarily been developed for bomb disposal experts who might have to work in very hostile environments. And they're in a lot of armor that shields them.
What was the movie?
Hurt Locker.
Exactly.
Yeah. Hurt Locker.
Exactly. I'm imagining he dressed up.
Exactly.
Yeah, that's got us in the desert too.
Exactly.
Yeah.
So, but all of those guys, they have to wear a suit inside, and there are microtubules in the suit, and you can infuse those microtubules with temperature-controlled water to keep the person wearing the suit cool. And we said, voila, this is what we need. Because you get that suit, you put it on volunteers. Now you can actually control the ambient temperature that is ambient on their skin by circulating temperature-controlled water through the suit. And so we started doing these studies where we would have normal volunteers in functional MRI, and we had these 2 reservoirs of water in the control room, and we had this pump that would just pump water through the suit. And you take that pump, and for 5 minutes, you put it in ice cold water. So ice cold water circulating through the suit. Then you take it out and you put it in normal controlled water. And all the time while we're doing this, we are acquiring the functional MRI data. So you might ask, well, where's the task? A few minutes ago, you talked about a task.
The task is
staying warm.
Exactly.
And you don't got to think about it.
Exactly.
The stress is produced from you just sitting here. Okay, it's going to be over soon.
Exactly.
Yeah.
And so what we did was we induced, and then we had a thermosensor that was on underneath the umbilicus. So we were able to gather skin temperature. We did not get into gathering cold body temperature.
I was going to say, bless those people. You had to convince them to go core. That'd be tough.
That you got to pay them a little more money.
Exactly. But what this paradigm does is it introduces what is called non-shivering thermogenesis. So your participants don't shiver, but they feel uncomfortable. Mm-hmm. And all the time while we are collecting skin temperature, we are also collecting the functional MRI data. And so now we have some signature of what is happening in the brain while skin temperature is dropping or it's coming back up. And so now we basically had a very basic experimental setup to study cold stress in the lab.
Now you have the mechanism to do it.
Exactly.
Yes.
And so one day, one of our students said to us, have you heard of Wim Hof? And I had not, because I don't use Instagram or this or that. But of course, I looked it up. We learned that this is a person who has demonstrated extraordinary tolerance to cold stress, to the cold.
Putting it mildly,
Yes.
That's the most mild sell of Wim Hof I've ever heard.
Well, he can sell himself. He sells himself.
It's true.
And so Otto and I said to myself, this person or people like him would be very interesting, quote unquote, this sounds bad to say it this way, but would be a very interesting specimen for us. Because we've studied normal volunteers, we've published papers on what happens in normal volunteers. But if we're studying cold stress, we want to understand what are the kinds of thermal regulatory mechanisms that we see in Wim Hof's brain, somebody who has extraordinary tolerance to cold.
That hits just the tip of the iceberg, forgive the pun, on Wim Hof. So for Mike, who really doesn't know who he is, I'm a fan. I think the guy's so interesting, and many other people do, but some other people might not who's listening. So give the overview of who this gentleman really is.
So in short, Wim is somebody who came into the public eye because he had extraordinary resistance to cold. And so in some sense, that's almost the least interesting part of what makes Wim somewhat interesting. I think what makes him more interesting is that over the years, he has amalgamated a series of techniques that I think he learned in India, primarily in India. Some of them are ancient Buddhist techniques. Some of them are quote-unquote Buddhist, quote-unquote Hindu, different kind of techniques. And he attributes his unusual ability to withstand the cold to the use of these techniques. There are 3 components to them. They include forced breathing, very heavy breathing, that hyperventilation that kind of changes the alkaline acid balance of your blood. That's essentially what it does.
Yeah, you're blowing off all your CO2.
Exactly. And this people have used before. So in the past, people use methods called dynamic meditation. It sounds antithetical. How can you have dynamic meditation? But the idea behind dynamic meditation is you're in a group of people and you're just jumping up and down, hyperventilating. You're completely throwing your body out of its equilibrium. You're throwing your cardiovascular system, your respiratory system out of equilibrium. You're throwing the internal neurochemical structure out of equilibrium, what we call homeostasis. What was big about that is what followed. So after people engaged in this dynamic activity for a period of time, they would just lie down in sort of a exhausted phase, and then they would sort of meditate. And so that's where the meditation comes in. So you have the dynamics and then you have the meditation. So some of what Wim does is either knowingly or unknowingly adapted from some of this. And then he has the exposure to cold. So he does this basically ice plunges. And then he has the meditation. Okay, so there are these 3 techniques, 2 of which are somewhat related to each other. The heavy breathing, the forced breathing, and the ice exposure, both of which target what is called the sympathetic nervous system. So you are really stressing your system. With the breathing, you're throwing your respiratory system out of whack. With the cold exposure, you're throwing your thermal regulatory system out of whack. The brain and the body do not like to be placed in these states. And the interesting thing about the brain and body is that when they are placed in these states in a very controlled environment, the brain and the body will react. And they react in what we call in ameliorative ways. So these kinds of stressors are called hormetic stressors. So hormesis is controlled stress, which is thought to exert some kind of a positive, or is thought to evoke a response from the brain and or the body, which eventually ends up being a positive response. Now, the interesting thing about Wim is that his method married these two hormetic stressors to what we call interoceptive focusing. So going back into a meditative state, what people call mindfulness, there are different terms that people use. They're not all synonymous with each other. So
the general idea being to go to like let go of all thinking and just kind of like chill.
As you have stressed your body, okay, as you have done this hyperventilation, this forced breathing, exposed yourself to extreme cold, now you come out and now you start to meditate. What's happening now is your body is slowly returning to its baseline. Okay, so the cardiovascular system is returning to baseline. The thermal regulatory system is now returning your body to core body temperature. And all the time while you're doing this, you're meditating as you're engaged in what we call interoceptive refocusing. So you are focusing on your internal body states as they come back to baseline. So as you stress the sympathetic nervous system, as the system returns to baseline, you're putting the nervous system in a parasympathetic state.
The automatic braking system.
Yep.
Exactly. Basically, now I'm relaxing, and I'm relaxing as my system is returning to baseline. So you have two techniques, which basically we called or we think of as hormesis enhancement, so the breathing in the cold exposure, and then you have the interoceptive refocusing. So we call this mechanism AIR, H-E-I-R, hormesis enhanced interoceptive refocusing. And anybody who has done it will anecdotally tell you that this seems to be much more effective than doing meditation. Like doing meditation is very hard. I don't know if you've ever tried it. It's very difficult to do because meditation actually needs a lot of top-down mental control.
And time, it seems.
Time?
To get into that spot where it feels like what you're saying is a condensed version of creating the state of disruption and then getting in the cold plunge and then getting out. We can do that in 10 minutes.
You can do that in 10 minutes. It's sufficient to do. You can do that at home, whether you do it with an ice bath or you just take cold showers.
I was going to say, if you just get uncomfortable is the whole point.
Yes.
Exactly. And so the idea is that you use these hormetic stressors to kind of accelerate a certain process, and you kind of knock the system out of its equilibrium, but in a controlled way, not in the way that it gets knocked out if you're in a uncontrolled, stressful situation, like you might be a frontline responder or if you're something like that. Those are uncontrolled situations, and those are psychologically very stressful. This kind of exposure is not psychologically stressful because you're controlling it.
Like you said, you just want the disruption.
Exactly.
I don't want it to leave a scar.
Exactly. No.
So it's like trying to find the least invasive, emotional, connected way to reach that.
Correct.
What better way for a mammal than to get super cold
Exactly.
super fast?
Exactly.
You are in a different mindset when you get out of that cold plunge than when you get in.
Well,
It's almost like a euphoric.
It's
feeling.
totally. You
When you
automatically
get out.
get that. But let me ask you this. He's also mentioning that refocusing after you get out. So do you focus on that or you go hop in the shower?
No, we actually do it as a group,
Okay.
and then
That's a big tub.
No, it's a one person, but we would go out there as a group.
Yeah.
And then while the others were doing it, we would sit there and
Be cold with them.
yes. And so then we wouldn't just go jump in the shower. It was that slow rewarming, and you had the kind of the camaraderie of being there with other people, you know, going through
It
it.
certainly helps. When you got everybody around you, it certainly helps.
It does.
A lot of us in the first responder community have adopted cold plunges. A lot of podcasts and a lot of really good data has come out on the health benefits of that.
Mm-hmm.
And what I'm hearing from you is there's more that's even expressed in the data from that. So tell me more about the enhancement, not just getting in there and all that stuff. Add to me that refocusing. Help me understand how the brain is changing and how this is really helping me beyond just the cold.
So everything that I will say now is speculation because we don't have any way to draw very hard conclusions. The theory that we've worked out goes something like this. So historically speaking, scientists thought that in the human brain, the autonomous systems, those that control breathing, those that control thermal regulation, these are very distinct and not amenable to top-down control by systems that are associated with awareness, that are associated with thinking, so on and so forth. And so in 2019 or 2020, we wrote a paper actually arguing, largely based on some of the embryonic ideas that we had on working with Wim Hof and working with some of this cold stress work, that it may actually be very plausible that under certain conditions, you can quote-unquote break this barrier. That is, you can use higher-order mechanisms in the brain to actually enhance the response from lower-order systems in the brain. So the brain, again, is thought of the cortex and subcortical regions. And the cortex, which we think of gray matter, or in some cases we talk about the neocortex, the new cortex, which evolved.
The outside, what you think of as the shape of the brain.
Correct, yeah. The new areas of the brain that evolved more recently in humans than older areas of the brain. But the idea is that some of these primitive areas are shared between species. So people talk about the cortex, the neocortex, and then you may have heard of the term the reptilian brain.
Yes.
Now, that's a simplification, but the idea is that there are certain areas of the brain that are very primitive, and they work on their own.
We talk a lot about the amygdala on the show.
Yeah, okay. So
we really do.
We do.
Yeah.
It comes up once an episode.
Yeah. So the idea was that the autonomous system was really not under control of willful regulatory systems. And we wrote this paper arguing that it's very plausible that what some of these old behavioral techniques are telling us, and they have been understudied. Remember, the science that I'm talking about, this Western science, is about 100 years old. A lot of these techniques developed in times or in areas of the world where scientific inquiry was not an established method or an established process. So they haven't really been scientifically studied. And so we made the argument that many of these techniques actually, anecdotally at least, are suggesting that you can actually break this barrier, or you can use conscious or willful processes to enhance what autonomous processes are doing. So maybe you can use them to enhance the release of endorphins or the release of cannabinoids, which may be released when sort of you are exposed to the kinds of stressors that we are talking about now. That's became sort of the pathway for us to come up with this theoretical model of hormesis enhancement. And so the idea is that interoceptive refocusing, or being in a meditative state, or mindfulness on its own happens in a certain physiological context, which is largely at baseline. So you're kind of in a comfortable state. You're asked to sit still, and you're now asked to train yourself to think about your inner states to the exclusion of the outside world. Now, again, there are many different types of techniques. So they're not all synonymous, as I said. But largely speaking, this is how mindfulness works. And as I indicated, and for anybody who's tried to do it, this is very difficult to master. It's extremely difficult to master. It's extremely difficult to ignore the sensations that you feel. It's extremely difficult to ignore the environmental context that you're in and to focus yourself inside, which is why there's a dark side to mindfulness. I don't know if you know about it, but in many participants, for example, it's been argued that people with depression or mood disorders could benefit from mindfulness. But there are studies that suggest that in many of these individuals, what this leads to is ruminations. So because it's very challenging to control their mind, attempting to do this actually exacerbates the condition that they're in.
We hear about a lot of this now. I think I can't remember who just wrote a book on this, on how many people are exacerbating their mental illness by almost going to therapy too much, focusing on essentially the idea being is they're hyper-focusing on their problems.
Yeah, I mean, that sounds reasonable. I don't believe that explains everybody, but
no,
it could well be.
There's a segment of people that need to just chill out and go for a walk.
Yeah, exactly. So the idea is that what if you actually engage in this top-down directed refocusing, when your physiological state is not at its optimum, but in fact has been knocked out of its optimum and is slowly returning to baseline. And so what you have is now maybe that makes this process a little bit more easy because you're focusing on what's happening to you as you go from a state of substantial discomfort, not life-threatening discomfort, but substantial discomfort, which under your own control willfully allowed yourself to be in.
You didn't just fall in there.
Exactly. You didn't fall into the lake and then you weren't thrashing around waiting to be rescued. You willfully went in.
Which is a strength all on its own.
Which is a huge strength because it means the system is telling itself that I am doing this. Yeah. I'm doing this because there's a certain predictive outcome that I think I'm going to expect from it.
I'm in charge.
Exactly. And prediction is a huge part of the human brain. We're studying this as well. How does the human brain attempt to engage in predictions about the future? Because even though we are backward-looking species, that is, we look to our past, that's what our memories allow ourselves to do. But those memories also allow us to look into the future which hasn't happened yet. And we, more than any other species, and in fact we are, I think, the only species which tries to control our future.
Talk about being a firefighter, command of a fire.
Yeah.
So when you're in charge of a fire scene, you're literally playing the whole fire out in your head in 5 minutes. The whole idea is in 2 minutes
trying to control each aspect of it.
And talking to everybody at the same time. So we can totally relate, and I can see police officers, dispatchers in those emergencies. But I know this guy's going to take 2 minutes to do this. This is going to take one, and you're doing this in milliseconds.
Absolutely. And the reason you're doing it is because it's adaptive.
Yeah.
It's a survival instinct.
Yeah. We're not even thinking about the process. It's just in there now.
Exactly. And we can ask, why are we able to do it? And there are a lot of neurobiological reasons that we're able to do it. There are lots of brain areas that allow us to do it. There are lots of systems like language that allow us to do it. But this is a goal of human predictive systems, to optimize our chances of survivability in the future. And it turns out that we do it not just consciously, but also subconsciously. Like our autonomous systems are also constantly engaging in predictive behaviors.
Mm-hmm. Like when you're about to run really fast.
Correct.
So if the whistle's about to blow and you got to sprint,
correct,
your body automatically takes that breath to pre-oxygenate.
Or
you're not thinking about that.
Exactly. Or, this example I use all the time when I teach this is you're driving on I-75 and about 100 yards in front of you, you see a car swerving. That car swerving, it hasn't affected you yet, but its swerving could affect you in the future. And so now you go into this mode. Not all of it is willful and conscious and aware, but you're probably at the back of your mind saying, well, is this car swerving because the driver is drunk? Is it swerving because there's something wrong with the car? And depending on what prediction you end up in, that will impact your behavior.
Yeah, slow down, move over,
exactly,
all the things.
And there's no straightforward answer to why this happens, but a part of it, when in neuroscience, you don't think in monocausal terms. So there's not one cause. It's multi-causal. But one of the causes that you see this phenomenon is because they have the experience of memories that sharpens predictive processing. Mm-hmm. People have known this from experimental studies. It's a very, very lucid framework.
Right.
And so getting back to the air stuff that we were talking about, it's your brain is constantly engaged in predictions. And so the advantage of exposing yourself to controlled stress is there is this predictive response that it engages in the brain and the body, that I'm doing this because I'm knocking my physiology out of homeostasis, out of its baseline for a very brief period of time, but I know it's going to return to baseline. And then when you go into that meditative state, you have this scaffold, if you will, of the system returning to baseline that your parasympathetic nervous system can actually hang on to. Mm-hmm. That is, I've activated my sympathetic nervous system. I'm feeling uncomfortable. But it's only for a short period of time because I'm not abandoned on the mountain. I haven't fallen out of a ship in the middle of...
And you know that subconsciously.
Correct.
So you're not freaking out.
Correct. So you don't have the psychological stress response that becomes very destructive when you're in a catastrophic situation. Mm-hmm. Like when people talk about climbers dying of hypothermia, what they typically die of is the bad decisions that the combination of mild hypothermia and psychological stress induce.
Yeah.
The fatal impact is not of the cold itself. Eventually they freeze to death, sadly. Mm-hmm. But the reason many of them freeze to death is they ended up taking bad decisions, where had they been in a more optimal psychological state, they could have taken good decisions and gotten to safety. So in this case, you don't have that psychological stress. You have the physiological stress. And so you have the sympathetic nervous system that you have activated. And then as you release that stressor and as the system is returning to baseline, now you have the parasympathetic system that is saying, I like to feel comfortable. This is sort of the rest and digest kind of system. But then the advantage is that as your system returns to baseline, there is sort of this placebo-like boost, if you will. So you expect the system to return to baseline. It does return to baseline. And now you feel really euphoric after that. Because, wow, the system was knocked out of sort of balance. I felt uncomfortable for a while. Now I'm just here relaxing, kind of bringing my attention to my internal body state. And when I started doing it, I was very uncomfortable. But now, after a few minutes, now I feel great. I feel fantastic.
Yeah.
I mean, if you think about it this way, this is not a complete neuroscience theory, if you will, but it's a speculative account which kind of makes intuitive sense.
Mm-hmm.
And it makes anecdotal sense. That is, people endorse this kind of a feeling when they go through this. And so the point is that if you do this as a behavioral intervention, if you do this as a regular practice, is it possible to induce what we call tonic changes? That is, that you change the system for the better. And that over time, it has huge psychological impacts for you. And the impression that we have from incomplete data, but emerging data, is that this may be the case. That this actually may be a kind of intervention that helps some kinds of people who don't need medications, but who probably get medicated because that's what people do. They get medicated. But for a lot of people who have, say, low threshold trauma, low levels of supra-threshold anxiety, so they're anxious, they have trauma, they have this, they have that, but they don't need medications. But rather they use a behavioral intervention technique like this, and maybe that it helps them maintain what they need to be on a day-to-day basis.
Yeah. It certainly brightens up my day.
And and see, the nice thing is that, and again, I'm speaking at a very high level here. I'm not speaking like a theoretical neuroscientist,
Sure.
But doing things like this makes you feel like you're in control. Taking medication makes you feel like you're out of control, if you think of it that way.
Even in the placebo way.
Yeah.
Exactly.
Right? Just being forced, quote unquote, and you're forcing yourself. You're saying, I need to do this. And many people absolutely do. You still have a feeling of, I got a medication, a leash. This chemical leash I'm stuck to.
You're not in control. The meds are in control. I'm quite certain that many people who are prescribed psychiatric medications probably don't need them. They are prescribed them for various reasons.
Sure.
Again, everything I say doesn't apply to everybody.
Sure.
We have to be very clear about that.
Yeah.
And it's not clear who what I'm saying applies to and who it doesn't. That's another question.
Yeah.
But I'm virtually certain that there are lots of people out there, more than we know of, more than we can even think of, who would really benefit from interventions that don't involve medications.
Yeah.
For the reasons stated.
So specifically for this, it also seems to be able to be a good stress trainer for first responders, because you can put yourself in a situation where I'm not emotionally stressed out, other than cold makes me sad and immediately. But you can use it as a tool to create stress, build resilience, and then that refocusing is a good odd time to train your brain to kind of be tougher and a more resilient is a better word when the poop hits the fan in real life. Mm-hmm. So I see it as that thing that also trains my mental toughness at 4 a.m. and we're doing something really, really stressful, and I can stay in the pocket, if you will.
That's the key. That is, it teaches you, if nothing else, to be uncomfortable and not to panic in uncomfortable situations. And I think that's the key. But it sounds like you guys are already doing it, so you already
there's two
know
out of
what you need to do.
millions of us, so...
Yeah, no, but I mean, I think we do. We live in a certain world of chaos, and we get uncomfortable a lot.
Yeah.
Right? I see it as like an enhancement of learning how to deal with that chaos.
Yeah.
You know what I mean? So it calms that mind because it's used to it.
Right. And think about this, Doc. When we started doing this at West Bloomfield Fire, where I work, we have a lot of lakes. They're beautiful.
Yeah.
And so when the ice was just right, not quite frozen, but the water still like should be frozen, it's cold enough, but it's not because it's moving a little bit. and then we all show up together, and then it turns into, well, I'm not getting out first.
Yeah, well,
So you get this really big dose, and then after we're like, I'm not going to warm up first, right? So there's the added benefit, I think, of that camaraderie of group work and really stressing together, and that bonding we talked about before recording, that really can bring you together as well. And I hope that this data can eventually show that this is worth our time and money on duty to build healthy humans, bond them together, and give them resilience training in the literal sense.
And like I said, we are doing it because we have a very strong belief that this is the kind of behavioral intervention. So we want to democratize it. That is, it's easily done by anybody. But of course, the question is, does this actually make any difference or not? And is it enough for people to say that they feel better, or do we need other scientific evidence from imaging or electrophysiology to show that? And just last year, we actually published a pilot study where we ran this intervention in 5 novices who had never been trained in the method. And it took a lot of effort to get data from them, because we had to get neuroimaging data from them in 2 different modalities: functional MRI, using the cold stress paradigm that I talked to you about. And then we also got something called positron emission tomography data, where we were interested in understanding whether cannabinoid receptor density in the brain changed. So cannabinoid receptors have been associated with the modulation of mood and anxiety. And so we trained 5 novices in this method. It took a lot of time. It was almost 50 hours of commitment per participant. Wow. Because when you're doing a scientific study, there's certain sort of criteria that you have to abide by. So data were collecting from them before they went into the intervention. Then we had 6 weeks or 8 weeks, if I'm not mistaken, of intervention, 2 hours every Saturday or Sunday morning on the weekend. And then they did cold showers, and they did the method on their own during the week. And at the end of the 6 or 8 week trial period, we collected brain imaging data again and psychological scales again. And we showed very compellingly in a very small sample some interesting things. One is that from the PET data, the cannabinoid receptor density, it went up after 8 weeks significantly in many areas of the brain, including those in the brainstem. And there isn't any reason for it to have this kind of fluctuation without the tonic effects of this hormesis enhancement, interoceptive refocusing. So it went up in many regions of the brain. With the functional MRI, what we found was activity in areas of the brain that we call interoceptive regions of the brain. That is, regions that are involved in assessing how we feel on the inside. Activity in that went up under the cold stress paradigm. And then we also found that across the group, changes in mood were loosely related to changes in cannabinoid receptor density. So in individuals in whom the change in mood had the most enhancement from baseline to follow-up, they're also the individuals in whom the cannabinoid receptor density increased the most. Again, no single study is conclusive. You do the study because you want to demonstrate a result.
You're adding to the conversation until it's so overwhelming in one area or another.
Correct.
It's been reproduced so much to where you can count on it being a result.
Exactly.
And that is science. When we say what is science, that is it.
Correct. So the science is how we actually did the study. The science isn't about saying this is going to work, so do it.
Right.
Science is about saying we think this will work for the reasons that we state, and then we go about doing a study where we manipulate. By manipulate, I mean experimentally study the process that we want to study. Then we look at the outcome and see whether it actually matches what we expected or not. And so again, no single study is conclusive on its own, but it strongly suggests that, and these were novices, they were typical controls, as you will. It strongly suggests that this is the kind of intervention that actually may have an impact.
Like you said, you're on the careful side of measuring and weighing all of this information.
Exactly.
And then separating the wheat from the chaff.
But the very fact that we are where we are suggests that things are changing slowly.
Oh, definitely.
I think
we
they
talk
are
about
for
all
sure.
the time how when we got hired 20 years ago, we've both been around about 20 years, and just the last 10 years. You could even do pre-COVID and post-COVID, right? and really do an analysis of, I think, every job on everybody looking at mental health. But that was the thing that really like, all right, enough. That just seems to be the date. It wasn't the event. It was the lockdowns. It was the constant stress. It was just the world imploding in on itself emotionally, that everybody's like, okay, this is real, right? We're all going to say it's real now. Where people stopped pushing it away and stopped telling people they were wrong for going to ask for help. And so when you just remove those two things, the stigma all of a sudden is dissolving.
Yeah.
It's not gone, but it's dissolving. It's a process. It's going to be a long time.
Well, I think it was also a time where all we had was each other.
Yeah.
You know what I mean? You couldn't necessarily go see somebody because, I mean, if you think about it,
You wouldn't even know where to start.
Zoom was born during COVID,
Yeah,
right?
it really took off.
It
Yeah.
took
When it
off
really
during
took
COVID,
off, you know what I'm saying?
Yeah.
And so you didn't have a therapist you could go see at that time.
Well, you didn't know it was so easy.
Yes.
You didn't know it was obvious.
We just had each other, really.
Truly,
And that's where I
yeah.
think the openness and being able to talk a little more about it, I think it stemmed a lot from that because you didn't have anybody else.
Right.
But we had to, we were all going through this same thing together.
And to give you a little more insight into that, most first responders I know that see a therapist got the recommendation from another first responder.
Yes.
So it is
Makes
such
sense.
a word of mouth to get you to go do it. I don't care how many commercials and
But
programs there are.
we wrote a paper on this recently. The other thing is that the modern world has become very stressful. And in the paper that we wrote, we made the comparison between, so the human brain has regulatory systems, right? So we have to regulate things. We can't just go and eat as much as we want, or we can't just go out and read as much quote unquote information as we want. So there's regulatory systems. And we as a species also have an evolutionary history. Like we didn't just emerge yesterday.
Right.
We've been emerging, we are being shaped by the environment for eons now. And the way that we see ourselves now is, in evolutionary terms, what Homo sapien is now is really a blink of an eye in evolutionary terms. And so you have to ask yourself, these regulatory systems, what evolutionary conditions did they evolve under and evolve for, and what conditions exist now? So let's think of food. For how many years have most of us have had food security?
Mm-hmm.
I don't know. It's probably maybe 100 years.
Yeah.
So till 100 years ago, and in fact, vast portions of the world still don't have food security. And so if you are a regulatory system that is designed for food intake, and that you have to work with a certain set point for food intake, but you are engaging, that system is engaging in predictive processing. So its predictive processing model is very simple. Its predictive processing model is, if you have food now, eat it. Because you're not going to have food. You don't know when you'll have food again. Fast forward maybe 70 years from your grandma. Are we ever in an environmental state, the way we live, where we ever have food insecurity? No. Yet, why do people always eat? Now, there's not one reason for it, okay? But one of the things that we have proposed is that the rapid transformation of the environment from scarcity, food scarcity, to food abundance has completely thrown the regulatory systems for food out of whack. And so now people just eat. You put 10 cookies here, we're going to eat it.
Yeah.
Part of the reason we eat it, of course, it's their satiety. We like the
It does
feeling of
taste
sugar
good.
and so on.
Yeah.
But as I said before, there is no, things with the brain are not monocausal. There are multiple causal reasons for things happening. And part of the reason that we continue to eat now is almost certainly the fact that we are still being governed by regulatory systems for food intake that evolved for scarcity. And so those systems are reflexively telling you, eat now, because you don't know when food will be available again. Well, the problem is that environment no longer exists. Food is abundantly available. So why now do we have all of these metabolic diseases that we see? A reason is because these regulatory systems that were evolved to deal with scarcity now have to deal with abundance. And it's a real challenge to deal with abundance. But if you think about it, the same thing is true of information. The regulatory systems that governed how we dealt with information were governed for an age when there was almost no information that you had available to you. But now you have, on a 24/7 basis, you have massive amounts of highly emotive information that is now abundantly available.
Doom scrolling.
Absolutely.
We have names for this stuff.
And
now.
does it make people happy?
No.
But we name it, but we don't do anything. You know, we all know it. It's like, I shouldn't be looking at my phone for 2 hours before bed.
A reason, not the reason, because there is no the reason, but a reason that this is extremely maladaptive is because this constant access to highly emotive information is throwing our predictive systems for the future out of whack, because now we are constantly simulating highly negative future scenarios all the time.
Yeah.
And what this does is increases anxiety, it increases depression. Why do you have such an explosion in teen anxiety, in teen depression? It's not an accident.
Right.
It's not something that some biological switch got changed.
They're all being impacted by this common denominator.
We all live in an environment. We bring a certain biology to it. We bring a certain evolutionary history to it. There might be some variability between individuals that we talked about, but there's still a lot of commonality. And it's no surprise that you now see the environmental impact interjecting in very maladaptive ways with the biology and the evolutionary endowment that we came in.
I'm a lot happier when I don't watch the news and don't stay off of social media right there.
I'm with you.
Yeah.
So
I don't use it at all. So.
Yeah, good for you.
It's a noticeable difference.
Yeah.
It's a noticeable difference.
I post and ghost. So with having the podcast, you got to post stuff all the time. And I'll look for a minute, but I'm off. I'm not dedicated to it in any way. My wife posts fun stuff of our kids. So like she tags me. I'll say, that's a good picture of this and that. But you got to keep it realistic for what it is and walk away. But I'm also at an age in my life where I don't really care.
Yeah.
I could see being in your early 20s and being sucked into that as a single young kid.
Or as a teenager.
Yeah, all the things. I could totally see the crazy things I would have put on the internet before my prefrontal cortex hardened.
Thank God there were not cell phones around. We were in our teens.
I was an outdoor cat before they had all that. Okay, so, sir, as we close out, for our first responders listening, perhaps struggling with any type of chronic stress or anxieties from any level, right? What's the actionable steps they can take for improving that resilience in the general way as we close out?
Well, you actually said a few things. One is find a way to self-regulate your emotional responses to the environment. And an obvious way is to stay out of emotionally toxic modulators of sort of your emotional state. So whether it's social media, it's easier said than done.
Maybe a cranky coworker.
I mean, cranky coworkers are hard to deal with because you have to work with them.
Yeah.
But you have to find a way to sift between the things that you have to deal with because you can't avoid, and the things that you can't avoid.
Mm-hmm.
So in a sense, I mean, I never got into social media at all. But I think that people can quote unquote self-medicate by getting off of it. So you don't medicate by just getting on things. You can also medicate by getting off of things. And I think that this kind of uncurated, rapid dissemination of lazy quote unquote information, I think it takes a lot for it to not evoke negative emotions in you. And I realize that, which is partly why I'm not part of this world. But I think that's really the fix that is under people's control. Mm-hmm. I actually was interviewed by a magazine called Parents. It's Parents Magazine, specifically on this issue. Mm-hmm. Like, what do you do if one of your teens posts something inappropriate online? And I said that to the interviewer, that there isn't one thing that you do. This is a process that has allowed the teenager to come to this point where they put something toxic online. And I think what you have to do as a parent is you have to understand, you have to stay engaged and understand the signs of that process as it's developing. And the most important thing you have to do is you have to set an example. Like if you're posting all kinds of stuff online, how do you expect to instruct your kid not to? And so for first responders, I would say the easy thing to do is to not get entangled in kind of toxicity that typically happens on social media.
Or maybe in the kitchen table, too. So let me give you a little insight to the kitchen table of a first responder community. The hens can start cackling.
We used to call
us. We can. You get John, the drama, the this, the that. What I'm hearing from you, too, is something you can remove, is removing yourself from the drama of work.
Yeah. So when you say kitchen table, you mean
literally the kitchen table.
We have at the firehouse.
At the firehouse.
Yes, that is our center of our universe. That's where we hang out. That's the town square.
And you could spin yourself up amongst the conversations. Yeah, can you believe they did that? And you know what it's like. It's a sewing circle.
Yeah.
And so you could get worked up, but then and a lot of people, the wisest ones will remove themselves from those conversations, knowing how that impacts them.
I think that's the key. So, a lot of this toxicity, you have individuals who feed off of it. It makes them stronger.
Oh, yes,
it's
they
their
do.
personality.
Correct.
Yes.
But then you have to decide, what are you? So if in my opinion, even if you are somebody who makes this kind of toxicity makes you feel stronger, you shouldn't engage in it. But if you're not one of those people, you definitely should not, because it has highly negative effects for you. Yeah. So this is the kind of easy stuff that you can do. Just kind of control. You can control the environment you're in. Like I do it all the time. I live in this world, but in some ways I don't live in it.
Right, because you choose not to walk down that hallway of that part of the house.
That's correct. Because
why bother?
It's going to make me angry, and I just I don't need that.
Yeah, I think he gives me a lot, as we close out, that gives me a lot to think about at work of, it's not about adding more to your to-do list. Sometimes it's just removing a few things that's going to take a lot of the stress away.
That's what I said. Medication isn't just necessarily something you take, it's something that you remove.
Yes.
I love that. The space between the beats to
Yep.
drummers is more important sometimes than the actual beat.
Yeah,
Yep.
That's well put. It's a nice way to put it.
Well, thank you very much for joining us
Thanks for
today,
coming
sir.
on. We appreciate you coming
I
on.
hope you and your audience found it interesting.
Yeah.
Yeah, absolutely.
This was cool.
Cool.
Yeah.
And I'm happy to do it again if you think that there are other interesting things you want to talk about.
Yeah, we'll knock on your office door.
Yeah, we'll walk about 5 feet and knock on the door.
All right, sir. Thank you.
Have a good night.
Great. Thank you.
Thank you for listening to the Minds on the Frontline podcast. We have more great content coming out soon. Please check us out on YouTube, Instagram, Facebook, X, and LinkedIn. And make sure to like and subscribe to all Minds on the Frontline podcast social media channels. Thank you, and have a great day.